Okay, we're team, there are four lights, and we're going to prove the equation of motion by using a system of pulleys, weights, and a cart. And basically, what we're going to do is we're going to move this cart to this end of the track, like that, and then let the weights drop, and use a computer and Logger Pro to measure the acceleration during that time. And since we know the forces and the mass, we can prove F equals ma.
Hey, my name is Danny Meyer. I'm going to be explaining the relation of accelerations in our pulley system for our experiment. From our diagram, you can see we're going to use the top pulley as a reference datum, and we're going to get the length SA of cord from the first mass A, and we're going to get the second length from the second mass B. That's going to be SB. These two lengths in our pulley system are constant, so we can leave them out of our length of cord equation. We've set it up, length of cord equals 2SA, because there's two lengths for SA, plus SB, because there's only one. We'll take the second time derivative, which will initially get velocity for each length, and then we'll get acceleration for each length. These will relate directly with each other, and we can see that we'll get 2 acceleration A plus 1 acceleration for B. That means that 1 acceleration in B equals 2 accelerations for A. This is saying that the mass B has twice as much motion as mass A.
I'm Caleb, and I'll be presenting about the free body diagrams and the movement of the masses. We've got the mass A has 2 times the tension 1 pulling up and its weight pulling down for a total downward movement. And that means that 2 times the tension minus the weight is the negative mass of the weight times its acceleration. And relating to the pulleys, we find that the mass of the first weight is equal to acceleration A, and we plug in the weight of A and its mass, and we find nothing yet. Next we have the cart. It has a weight and a normal force, and the 2 tensions pulling to either side, and it's going to move to the left in the end. So we have tension 2 minus tension 1 equals the negative mass of the cart times A of the cart. We plug in that A of the cart is 2 times AA, and then we insert the mass of the cart, and we will have our second equation. And finally, we have weight B. It's got the second tension up and the weight down for an upward movement. So T2 minus W2 equals M2A2, and A2 equals 2 times AA, and we plug in the weight is 0.49 newtons, and its mass is 0.05 kilograms, and we have all 3 equations. We solve to find out that T1 is 0.64 newtons, T2 is 0.5 newtons, and the acceleration of A is 0.13 meters per second. So finally, the acceleration of the first mass is 0.13 meters per second squared down. The cart moves at 0.27 meters per second squared to the left, and the second mass moves at 0.27 meters per second squared up.
Hi, I am Abdulaziz Nafisa. In my group, we do a project about Newton's second law, and we need to prove that based on the experiment and calculation. As you see in the experiment, we did to find the acceleration of the car by 2 pulleys, and here we make it by calculation. The acceleration, when you get it in the experiment, it will be most slightly different from what you got in calculation. But there are 3 reasons why it's different. Because in the experiment we ignored the friction. The second thing, the slope of the table can be affected on the value.